to introduce our next speaker. He is an expert in all aspects of software testing and quality assurance. He's the founding chair of the ISEB Tester Qualification Board and the host and organizer of the UK Test Management Forum conferences. He has won several Best Presentation Conference prizes and was awarded the European Testing Excellence Award by Eurostar Conferences in 2010 and the Lifetime Achievement Award in 2013 by the European Software Testing Awards. And to deliver the keynote on how to test the Internet of Everything, please welcome Mr. Paul Gerard.
Am I on? Am I on? Hello? Hello? Can you hear me? This is a big stage. I did a talk in, can you hear me? I can't hear any kind of feedback. I did a talk in Sweden some years ago, and as is my wont, I tend to have a habit of walking around. And I was doing my walking around, and I was using sort of whiteboard and drawing pictures and all this kind of stuff. And right at the front was a lady, I say little old lady. She was a little bit older, okay? And as I walked to the edge of the stage, I could see she was going like that. I'd do it again, and I said, sorry, I need to stop. I said, are you okay? And she said, no, I'm fine. I think you're going to fall off the stage. So I said, nah, don't worry. I've been doing this for years. And then 1 minute later, I fell off the stage. So I'm going to stand behind this thing. Okay, so I want to talk about testing the Internet of Everything. And I have my little controller turned on. Okay, so for the past 2 years, maybe a bit longer, I've been paying attention to what has been called the Internet of Things, Internet of Everything, pervasive computing, all that kind of stuff. And the fascinating aspect about it is it's fascinating. It's promised to be huge. You know, today we have 5 to 7 billion devices on the planet. In 10, 15 years, who knows how long, there'll be 100 times as many. So the Internet will go from 5 or 7 billion to 5 or 700 billion devices on the Internet. Now this is kind of, no one really knows, of course, whatever. But it struck me that, is it just a matter of scale, in which case we just need 100 times more testers? Or is it a matter of complexity? Or is it a matter of, actually, 99.9% of these devices don't matter, so we don't need to test? And I was curious, so I've looked a bit further into this. So I want to talk about some of the research I've done and also some of the experience I've got in playing, let's use that word, because I'm not a serious developer in the Internet of Things, of playing with devices. So everything works, so now I need a drink. So the argument is, and the current thinking is, that the Internet of Everything will dominate our industry for 10 or 20 years. It's as important as the Internet itself. So if the Internet started, I don't know, 15 years or so ago, now look where it is. The Internet of Things is just getting started, really. In 10 years, 15 years, it'll dominate our lives. That's what people are saying. But right now, it's very confusing, because the big players, the IBMs, Cisco's, Microsoft, Oracle, etc., the really big corporations are investing a mountain of money in this. But it's not clear to you and me and the person in the street what's going to come of it. The discussions are taking place at board level, and we mere mortals don't know what's going on in these boardrooms. We see little snatches of the possibilities, but most people are not yet working on the Internet of Things. But I believe in a few years we will all be working on the Internet of Things. So right now there are a few standards. Standards are emerging. It's really like Dodge City, anything goes, okay? In time there will be standards, but right now it's a very confusing place. And most people sort of say, yeah, the Internet of Things is fantastic. The only thing to worry about is security, and privacy, and scale, and the more you look at it, the more you think, wait a minute, this is more complicated. So the challenges we have, I'm going to talk about these a little bit further into the talk, but there are broader societal risks. So in the session before lunch, I should say, the session before lunch, I talked a little bit about testing and automation, but I had this idea while I was asleep that I want my own personal drone, okay? Little flying thing. So when I get out of bed in the morning, I get in my car, my drone takes off, and follows me. So if I have an accident, or I get robbed, or murdered, or whatever, my drone will film it all, and the evidence is there for all to see. And then I think Brian sort of said, I wouldn't want my wife seeing the video of this. And that's the point. These drones might not be your drone, it might be someone else's drone. And how will you ever know? Because they're going to cost a few dollars, a few ringgit. They're going to be so cheap, they're going to be absolutely everywhere. And kindly people will use them, and criminals will use them. And how will they be regulated, if at all possible? How will the legal authorities catch up with the possibilities these things open for criminals? Okay, so let me expand on that over the course of the next half hour or so. So this talk isn't just for testers. This talk is for... my zapper doesn't work. Can you see that? Not really. I can see it. There's a dot there. Governments need to listen. It's not just about individuals and companies. It affects governments as well. They are going to have the tools to make our lives very interesting or unprivate, open, and it's a bit kind of scary at times. So what I'm talking about right now is based on 3 papers I wrote last year. So there was a kind of a series I wrote for the Tea Time with Testers guys in India. And essentially, the first paper was like, what is it? The second one is, what are the risks? What does the architecture look like? The third one is, how are we going to test this? So kind of today I'm talking about the third area. So it's on our website. So what is the Internet of Everything? Let me just, I should read my slides actually. Because one of the things that we have is the Internet of Everything includes everything. And that's the point. So let me start from the bottom. The easy way up, if you like. About 2 years ago, I bought myself an Arduino, a little microcontroller board. How many people have got Arduinos? How many people have got one? Got one in the test lab, and a chap down here. Okay, get one. Learn how to program. Have some fun, right? So I can't point these things out, but okay. Where are we? Bottom middle. Okay, bottom middle. That is a proximity center. So one little, it looks like 2 little tin cans. It's only about so big, about 2-3 centimeters. One sends out a signal and the other one listens, and it's a radar. It's radar. So you can detect the distance away of any object. You hook that up to your Arduino, and you can do a beep when and it calculates the distance, and you can have high frequencies when it's close and low frequencies when it's far away, and you can make music, okay? For a few dollars. The middle on the left is a servo. It's an electric motor, also called a stepper motor. So you can program it to move a degree at a time, very precisely. So you can put this on top of your robot to direct your laser beam. So I've got a laser beam today that doesn't work very well. Okay, but I've got a device at home. It costs me about $1. And I can control, with software, a laser pointer. We meet again, Mr. Bond. Now, these devices cost between 20 cents, I'm talking US, okay, let's do it that way, between 20 cents and maybe $1. These things don't cost much. If you buy them in Europe, they're a bit more expensive. If you order them from China on eBay, they're half the price, so that's what I do. You have to wait a few weeks, but they arrive. So I've had great fun building things. And I recommend, if you get the chance, to do this, because your kids, if you have kids, are doing exactly that at school. They're buying Raspberry Pis, Arduinos. There's the BBC in the UK have commissioned a little device now. It only costs about $1 or $2 or something. Remarkable. It's a computer on a chip and programmable by kids. And that's what's going to be out there in about 10, 15 years. Our kids are programming stuff. Eventually they'll be programming stuff on the Internet of Things. So I built a robot, and I'm not going to show a video, but I've got this video with me and my hairy legs because I was wearing shorts at the time, and it took me 1 day to create a robot from scratch. It took me half a day to build, put the hardware together, to screw it all together and wire it up, and then I wrote some software. So on the top of the robot is a Raspberry Pi. So that was hosting a website. Yes, you can host a website on something that costs $20. And I had a tablet, and I accessed the website on my local wireless network, and I controlled the robot. And each wheel, I can programmatically cause them to go forwards and backwards. So I could go forwards, backwards, left and right by reversing the direction of the wheels. It took a day. 1 day and about, I think, $60, something like that. And a reusable computer and a reusable robot that I can do other things with. Oh, and I can put a laser on the top. Oh, and I can put a proximity sensor. I could put 3 or 4 on so that actually it can avoid obstacles. Oh, and I can put a thermometer gauge on it. Oh, I can put my mobile phone on it and connect to that through the USB and use the sensors on my phone. Do you know how many sensors are on your phone? Accelerometer, magnetic field, the whole gyroscopic ideas and geolocation, all that kind of stuff, it's all there. The point is this: the cost of entry into this market is so low, and so many people are experimenting, that there are hundreds of thousands of inventions being created every week, month, maybe year. Most of them are going to be complete rubbish, but some of them are going to change your lives. And they're going to start looking like a box of garbage like that. But I do want to show you a little video. I don't need the sound. There is no sound. Okay? See what you think of this. That's at real time. Real time. Three times. Walking on a skin. I'm sure he's doing this, isn't he, to keep it from falling. Delivering a block. How big is it? It's so big. It can swim. Can carry loads. Climb mountains. Digging. So we're all out of work. And they made one out of polystyrene and it dissolves. I'm not sure why they show that bit, but you told me it dissolves. So what? Are they saying they put it inside your body and it dissolves? Oh yeah, maybe. This one's too big. But there's stuff called smart dust. And the definition of smart dust is a computer in a space the size of a grain of sugar. A little sugar crystal. Smart dust. Watch out. So these things are coming. Isn't that great? Don't think? Okay. So, all things are becoming possible. So we have these kind of communities called makers who are building stuff from Raspberry Pis, Arduinos, and so on, and making kind of interesting gadgets. But they're all getting together in a huddle, and they're all helping each other to make stuff, to invent. And the barrier to inventing new devices is so low, we're going to see so many of these inventions come so soon. Okay, they're beginning to emerge already. But what you're seeing now is the first 1%. Okay, we haven't seen anything yet. The stuff that's on the horizon is just terrifyingly fantastic. Fantastic because it's remarkable and just wonderful. Terrifying because, you know what, we're not the only people watching for these things. You know, the criminals are out there too. Governments, if you regard them as criminals as well or not, but they've got their eye on this stuff as well. It's all on the way. So people like Siemens, these are just, randomly I just chose some web pages where people are talking about, the next network, Siemens, what's the next network? Internet of Everything. Learn about the Internet of Everything, 19 trillion in potential value. That's why Cisco are paying a lot of attention to this. $19 trillion? That's quite a lot. IBM announces a $3 billion investment in Internet of Things division. So they're investing $3 billion. I think they want to make more than $3 billion in business revenue, don't they? They're doing this for a reason. They believe there's something really, really big just on the horizon. So I didn't go to Smart City World Congress, but I think just the title of this is people are not thinking about mobile apps or banking systems or whatever. They're talking about smart cities. Cities the size of Barcelona, which is a good sized city. Barcelona are trying, they've got this ambition of becoming a smart city, which is fully connected, metropolitan networks all over the damn show, as many of their services as possible controlled or administered or delivered through local networks. So it's a big deal. They're designing cities on the basis of software. That's never happened before, has it? That is not a real city. That's a city in the making, based on software. Isn't that a bit scary? So, Hackaday. I mean, there are some fun things as well. So this guy here, and I said it before lunch, this guy has connected 4 crates of beer to his little contraption, and apparently it takes off and carries 100 kilograms or something like that. And I have to say, well, surely you want to bring the beer rather than take the beer away, but whatever. We'll move on. A printed car. A 3D printed car. What's that all about? So cars aren't manufactured in Detroit anymore, Motor City, But is the day coming when cars are not manufactured, you basically download some data, forward it on to your local printing business, just like paper-based printing, and they deliver your car for you? Is it going to be like that? I can't believe cars are actually ever going to be produced that way. But some objects will be. You will order data and have it locally printed. I saw a device, a video on, YouTube, I guess, which was a transporter, which is kind of interesting. You put your little contraption, a little device or your little component into this box like a microwave. And inside there's a milling machine, and what it does is it scrapes layers off your object. It destroys the object, but it records the data, and then it can transmit that data and print it, 3D print it. So it's a bit like the Star Trek thing of transmitting objects, transmitting people. Of course, we can't transmit people, but any object could be transmitted. You don't need to have the machinery to make things other than a 3D printer. So little components, for your photocopier, little components for your guns. Anything. And that's the good thing, the good news, the bad news. These things are as useful to bad people as they are for good. And that's a worry for us, I think. And I showed this morning. I believe this is Shanghai's road traffic network, controlled by these bunch of guys down the bottom. And I just have to laugh because I think they are not in control of this, are they? They can't control the traffic. So that's the kind of the fun stuff, or not so fun stuff. I need to talk about architecture. How are we going to understand the complexity of the systems that might be built on the basis of these tiny little devices, many of which cost 20 cents, and we have them by the billion connected in our world? How are we going to get our heads around this? We have to model it in some way. So, people know I'm a big fan of models, but I'm going to give you a 7-layer model. It's my way of looking at the world, and it's not entirely original. Well, it's not original at all, really. What I've done is I've taken some of the manufacturers' architectures, because they've all got different ones, of course, because they're in competition. So there is no standard because standards come when the competition has been taken away. Right now, there are competing standards for architectures. They're in competition. So nobody right now wants to let go. Everybody says, this is my architecture. And that's why it's a little bit confusing. Depends who you talk to, what the architecture is. That's no good for us. We need to have our own understanding. How are we going to understand this? So some patterns are emerging. And what I want to show you is well, it is what it is. Okay, here we go. 7 layers. All layered architecture layers have to have 7 layers. Don't they? By definition. OSI, remember that one? So here we go. At the top I've got application, at the bottom I've got device. What are these layers? What do they represent? They don't represent hardware. Don't get me wrong. They represent functionality. So the device at the bottom might be a temperature sensor or a proximity gauge or a servo, you know. It might be something to measure humidity, you know. Now that device, like a proximity sensor, would be packaged up with some networking card, little device, and connected either wirelessly or physically by wire. It might be a little package, which is the little box you put in the wall in your hall, which is your burglar alarm. Okay, that would be an object. It consists of several devices connected to a client. And a client would be like the controller of the burglar alarms around a house. So the little box on the wall that you have with your burglar alarms, that might be the client. Now the client might be connected to what I will call a propagator. And a propagator would be a box that sits in your house that all the devices in your house connect to. It's sat right next to your broadband modem. So it is connected to the internet. So your fridge, your TV, your children, yeah, you, the dog, the burglar alarm, the temperature sensors, the humidity control, all that other good stuff, you know, all goes through the propagator. And then it's to the outside world, and the internet, the public internet. At the other end of that is what you might call a filter gateway, which in some ways is like a firewall. It filters out traffic that it has an interest in. So at that point, the filter gateway is in a data center somewhere. The filter gateway then connects to an integrator. An integrator takes the data from all your devices and connects them to other systems, big systems possibly. So if you have a heart monitor and a location, like a fitness device, a wearable fitness device, you know, so I use a thing called Map My Ride. So my mobile phone records where I am. It can do that through GPS. When I say save, it saves that data to a web server somewhere on the planet, and then that is integrated with Google Maps. And I can get a map which tells me where I have cycled. It will tell me how many calories I've spent, because it knows the contours of the earth and knows how many feet up and down I've gone. Pretty good. So the integrator connects system to system, data to data. The application sits on the top. So my little app on my phone, okay, is like where the real value is to consumers, or value to governments, crooks, whoever. Now in some ways it's a little bit different from that, because I should have clicked a bit. A mobile device actually includes the first 4 layers, and also accidentally runs the app. So it's more complicated than this, of course it is. But the hierarchy of function is kind of the app is at the top and the device is at the bottom. Devices are very simple, the application is where all the value comes. Okay, you get the idea. So what do we know about architected layers? We know that they have to integrate. So we have integration at many layers. Some devices, some objects will include multiple layers, but the functionality included in those layers kind of follows this pattern. So it's just a way I've been using to try and explain what I believe is going on. Okay, so drivers. What do I mean by drivers? What's driving our notion of development of the Internet of Everything and how we test? So what's influencing us, if you like? I want to argue this, that the Internet of Everything will be everything on the Internet soon. Okay? So, do we need a strategy for testing everything? Maybe we do. All I'm trying to do now is just to give you a sense of what's involved out there. It's not a done deal. It's very early days. It's like client server in 1988. It's like the web in 2002. It's like mobile about 5-6 years ago before smartphones came along. We're still at the toe end of it. There's plenty of time to get our heads around this and plenty of opportunities to make millions out of it. You know, go and buy your Arduinos, Raspberry Pis, go and build something now. There's plenty of time to do this. You know, there's gold in them thar hills. Just get yourself a spade. But you know what? There is no money in the hills. The money is in selling spades, as you well know. So I want to suggest that the challenge we face is different from before, okay? The scope of the Internet of Everything is growing, so it's a marketing term. The scale of the Internet of Things, the Internet of Everything, is, you know, creeping up and getting bigger, but the marketeers are driving the hype that surrounds it. So the scope is right now being driven by marketing, not by technologists. Technologists are coming up with fantastic ideas, but it's the marketeers who are making all the noise. The Internet of Things, the Internet of Everything, will include objects in homes, cities, work, hospitals, yeah, wherever you go. Hotels, obviously hotels. Wearable stuff. You know, I mentioned contact lenses with software in. I can't get my head around that. I can't get my eye around it. I don't know, whatever. But there's the whole notion of everything you touch could be connected. No, that's rubbish. That's rubbish. That's never going to happen. Do you want to bet? I bet you in 10 years' time, every glass, every table, every cloth, every knife, every fork, every spoon, every plate, every person, if you carry your room key with you, will be connected. Why would a hotel want to know where every fork is? Well, you know what? If it knows where every fork is, it doesn't need as many. It's as simple as that. So watch out. So when you go, you know, with your case, say, bye, I'm off, and you go, and the alarms go, dee-da, dee-da, and you're stealing towels, cups, saucers, knives, forks, whatever, beds, you know, you will be caught. Watch out. But that's where it's headed. It's absolutely inevitable, I think. That's the thing. So my argument is this. The test strategy for the Internet of Everything is the test strategy for everything. That's the challenge. Once more with feeling, the test strategy for the IOE is the test strategy for everything. I really do mean that. I'm convinced that's the way, not today, not next year, but in 10 years' time, I don't know, that's what we'll be talking about. There won't be an internet, it'll just be everything. Now, isn't that going to be fun? So is it the biggest thing in 30 years? I think it is, you know, and I'm not convinced by the hype. I just think it seems so natural. If companies like IBM are investing billions in this, they're going to make it work. They're going to make it happen. They're going to sell it to cities like Kuala Lumpur, London, New York, Barcelona. Oh, they've already sold it to Barcelona and other cities as well. It is going to happen. So if we're going to move from 50 to 70, from today of 5 to 7 billion to tomorrow, in a few years' time, 700 billion, we're on a journey that will increase the scale of the internet by 100 times. How are we going to test it? So where am I now? Okay. I was expecting a different slide because I changed my slides this morning, but I left my memory stick in the laptop downstairs, so I haven't got my update version. Never mind. Here's a bit of history, okay? So, does anyone remember testing green screens on mainframes or mini computers? I remember writing code. I didn't do much testing, as I recall. But then GUIs came along, client server, internet, mobile. Now we're on the Internet of Everything, another roller coaster. The biggest one of all those was client server, not the internet. Client server was the big change. Client server was the big change because the internet is just an example of client server. Client server said software, data can be distributed. The internet just standardized it. So client server came along in the mid-80s. The internet came along 15 years later. You could say the standard for the client server came along 15 years later. Does anyone remember testing client server stuff in the 90s? Everybody wrote their own middleware, which it didn't work. It was rubbish. You know, you go and say, okay, what's the problem here? Let me guess. You've written your own middleware because everyone was doing it because there was no standard. So all I'm trying to say is we are in 1986 terms for client server. The standards, people are fighting, arguing, competing. And I met a lady I heard a talk. I met this lady in Barcelona at Mobile World Congress. 92,000 people. It's the biggest show I've ever been to. Kind of a lot bigger than this show. And all the talk was Internet of Things. The mobile industry believe Internet of Things is their business. They own it. It's their show, okay? But it's not just their show. But there was a comment there which said the technology that will connect the Internet of Things has not yet been invented. And she may be right, she may not be right. But I thought that was an interesting thing to say. That's where I'm convinced that actually we are still on the very early days of Internet of Things. Now, okay, so what's the impact on us as testers? I want to argue that the impact on us primarily, okay, security, big deal, privacy, big deal, but we understand these things already. We just need to be very careful and we need to work really hard with them. What's new, okay? And I want to argue that the biggest thing is this idea at the bottom, this functional testing and simulation at very large scale. We need to do functional testing, but the number of test cases we might need to execute in a distributed Internet of Things application where you have machine-to-machine communications, the number of test cases won't be 2 or 3, or 2 or 3,000, or even 2 or 3 million. It could be tens of millions. It really could. Because we've got 1 million devices in the test lab. And it was like 1 or 2, 3 tests each. You know, is it going to be as simple as that? I don't think so. It's going to be much more complicated than that. So we have functional testing at very large scale. That is often called simulation. And simulation we know how to do, except that it's ferociously expensive. Another aspect I picked up from Barcelona in March this year, there's a shift of power in the boardroom in that who gets the budget for IT? It used to be the IT director, but again, the vibes, you know, the word on the street was, in Barcelona, in the mobile space, was that the marketeers are going to get control. On the one hand, you think, great, we're getting the techies, it's going to be the business controlling IT from now on. But have you ever had a marketeer as a stakeholder? Are there any ex-marketeers in here? I hope I don't upset you. They are crazy. They want everything, and they want it now, and tomorrow they'll want it again. And again, and again, and again. And they are the worst stakeholders to have because they can't make their minds up and they are like a feather in the wind. Wherever the market takes them, they follow and they struggle. They want change after change after change. They want experiment after experiment after experiment. They want software releases every damn day. If you can deliver them, they would be delighted. Because they have this thing in their head, this idea, this notion of market testing. Let's try it, put it out there, experiment. If it works, let's roll it out. If it doesn't work, let's withdraw it and think again. And let's do that every single day. Because we've got more ideas than days in the year. So we're going to have to do this at least once a day. Right, says the IT manager for a bank. You know, we're going to have to move from annual releases to something 360 times faster. Is that right? Is that possible? Is that feasible? Almost certainly not. But online businesses believe that's the only way to succeed. They're all creeping up, creeping up, creeping up. They're using Twitter and Facebook and social media, as you heard from John this morning, the SMAC stuff, social media analytics and in the cloud. That is what's driving software development in the online businesses. I think Microsoft coined the term data-driven development. So we take data from production and that tells us what to do next. Which is kind of corny, but maybe that's the way it's going to be. But the issue we have is we have to change the way we think about software delivery if we're going to keep pace. So we have pressure from all sides. We have to do a lot more with a lot less, a lot faster, a lot more often. Oh, this is just impossible, isn't it? And the only solution I'm aware of that gets anywhere near to this kind of ideal is DevOps and continuous delivery. Those are the only guys who seem to say, yeah, bring it on. They're the only people saying yes. So if the marketeers have the money, and the only people who are saying yes to this regime are the DevOps and continuous delivery brigade, they're going to get the money. And they may be your boss, who says, I've read it in an airline magazine, or I heard a guy called Paul talk at a conference, this is the way to go, let's do it. So watch out, it might be coming your way soon. So the whole notion of analytics and testing and test metrics is kind of, it's all going to be one thing. You know, why does testing stop once we go into production? When it goes into production, we monitor it. I think you will see dashboards which include pre-delivery metrics and post-delivery metrics. Stuff that's driven by social media and production usage, and stuff that's driven by our need to keep pace with this hectic delivery schedule. And one last thing is, one of the reasons I think DevOps is succeeding, I think only a few % of the market, but it's succeeding, that's the main thing, is that people have an attitude to it that these DevOps processes are like sensors on our software delivery process. They're like sensors in the Internet of Things. Our DevOps processes are things on the Internet, like everything else. So our software delivery process is something that we've monitored just like other things on the Internet. So software delivery is part of the Internet of Things. And that's kind of weird, isn't it? You know, the human being who's delivering the processes, you know, thinks the process is separate to me. It's not. You are part of the process. I think we'd call that systems thinking, wouldn't we? Systems engineering. It's changing everything, and this is why I'm kind of excited by it and also terrified, because, you know, I'm probably too young to see the end of this journey. I'll do my Martin Luther King speech in a minute. I'm not going to make it up the mountain, but God, it's going to be fun when you get there. Okay, so Mark Zuckerberg, for example, another little aspect of this is he's got this initiative called internet.org. Go and look it up. I'm not inventing this, it's a genuine thing. He's using that as an initiative to try and connect the unconnected. So half of the planet aren't on Facebook yet. So he wants to get them all on Facebook. So he's trying to drive connectivity for the people that are out there in the countries that haven't got the infrastructure that we have in the West or the developed countries of the northern hemisphere. And you're in the southern hemisphere. I'm going to get myself in a lot of trouble now, aren't I? Wherever we are, you know, and my geography is not great. The people who aren't connected today are not going to put down copper to connect their towns, cities, and villages. They're going to go mobile. It's the only way to go. So kind of they're going to skip 2 generations of copper wire connectivity. So they're starting from a very positive position. And the goal of Facebook is to deliver connectivity to these millions, billions of people at 1/100th of the cost that the Westerners, Easterners, you know, developed countries have. That's his goal. I think the data providers, the carriers, have got something to say about that, but he's quite a powerful guy. So I think, as I said, you know, this quote, no technology dominates yet. We're waiting for technologies to improve in range and performance. The standard technology for connecting the Internet of Things hasn't been invented yet. That's kind of interesting, which it makes me feel that it's going to be, the excitement is all ahead of us, not behind us. So, what page am I on now? I'm going to talk about testing now. I've got to wrap up now. Haha, and get off stage. This is the hard bit, isn't it? Let me just drop some hints about how I think it might work out. This would be the first 1% of your test strategy, a guesstimate of how the testing might look. So every bullet that's coming up is kind of, this is an aspect of testing that we have to pay attention to in our strategy for the Internet of Everything. Hardware level functionality, these little devices, they're going to be tested by the manufacturers. I hope we don't have to test our proximity sensors. I'd hope we don't have to test our thermometer gauges and stuff like that. So let's not worry about hardware level testing. It's important, but that's the supplier's problem. Object and server level functionality, yeah, just like we did in client server days and as we do now in distributed networks and distributed systems, We have to test simple web apps to access to systems with many complex subsystems. There is an integration challenge we have to do, to take on. And how do we do integration? How do we do testing in the large? We break big systems into small systems into subsystems and units, and we have this hierarchy of testing. Most of it driven by test automation. I don't think any of this is going to be done manually. I don't see how. Unless you're building a really trivial application. The serious applications, it's going to be 90-something% automated. It's got to be. We have integration and interaction at all levels. So integration isn't just about software to software. It's not about hardware to hardware. It's not about people to people or machine to machine. It's about everything to everything. Every bloody thing to every bloody thing. So the number of interactions and integrations we have to worry about is much bigger than it was. Because the user interface, why don't we say user integration? The interface between a human being and a system is an integration point. We have to take much more seriously how integration operates at every level, from the first line of code to the second line of code, to the city, to another city. That's where we're headed. Otherwise, it's just going to be a mess. I've invented this thing called collaboration confusion, because I think we're going to have some fun with, for example, driverless cars. So you're going to be sat in your driverless cars, going to a meeting, and the car is discussed with all its car mates, all its friends in the crowd of cars. It's debated which spaces are allocated to which cars. So my car is very happy going towards its space, and then some joker, some kid with a beaten up car takes my space. So the car's going to say, our space is gone. I'm going to have to find something like musical chairs. It's going to have to figure out and negotiate another space. But then the potential for the knock-on effects and the queuing and the recalculation and recalibration of all this sort of stuff is going to confuse the cars, and I know it's going to confuse the occupants, the passengers. We have a new problem of confusion between systems which have not been tested in the, let me think, 100 billion ways they could go wrong. You know, if you have a Swiss watch, it's got, 200 moving parts, and it's absolutely precise and calculated every moment in time. Every piece connects with every other piece. Well, 90% of the stuff I need to test against, I have no control over. Some of it is controlled by criminals. Some of it is controlled by governments. Some of it is controlled by acts of God. And I've got to test all permutations, all combinations, because all permutations, all combinations are going to happen in the real world. How am I going to get around this? So people are going to die because of this. It's absolutely inevitable. Or we make all our driverless cars go at 2 miles an hour. And I don't think that's likely. Do you see where I'm going with this? This is a challenge, and I don't think enough people are thinking about it yet. So testing at scale. Yes, we have to do some performance testing. Well, yawn, we know how to do that. I'm not going to worry about that. But we have wearables and embedded. How are we going to test wearables and embedded? By the way, I mean embedded in your flesh. So there was a BBC reporter went to a company in Sweden who builds these embedded systems. And he sort of said, tell me about your embedded systems. I said, well, you can't come in the building unless you have this little device implanted into the fleshy part between your finger and thumb in there. So he said, okay. And it's about the size of a grain of rice, and they take a gun, and you could see the reporter going, like that. Once he had it, he could open doors, he could order lunch, get a coffee, the building, other people, Outlook probably, Exchange, probably knew where he was in the building. That was the business of this company. Now, it might be a bit painful, but it's a lot more convenient to carry that device, not worry about it, than carrying a phone or a watch or what the hell. So embedded, I think you will find you will be given the opportunity to have things embedded in your body to save you effort and time. The thing is, though, there'll be so many people offering these things, you're going to be full of junk, aren't you? So when you go through the airport security, it's just going to go crazy, which will be an interesting knock-on effect. Everyone's journey will be slower because everyone's having to stop because they've got to be scanned. Everything connected but moving. Now, mobile phones, yeah, they move, yeah, but they don't do very much. I mean, phones are clever, brilliant stuff, but they're basically running the same application wherever they are on the planet. It's just the locality and the distance from a network and running out of power and stuff like that. Okay, we've got all that as well. We'll have to do location-based tests because location will be significant. If we're testing driverless cars, you can't just test it in the lab and have random roads. You have to use real roads, and you have to use real traffic patterns to see what happens to the traffic patterns when things go wrong, like when it rains. You can't say, oh, we've tested this, but the one thing we haven't done is we haven't checked for when it rains, and that affects the behavior of people in cars. They drive faster, they drive slower, they take different routes, they get the bus, whatever. We have to start thinking about scenarios which are much more sophisticated in terms of the complexity. I think it's inevitable. Moving mobile networks. I did have this, I used to call this mobile networks, but that doesn't mean it. These are networks that move. So your car will have its own local network, and every car will have its own local network. You sit in the car, your devices connect to the car, and then they're connected to the outside world. You can pick up your email in your car from the internet, maybe. And these things are beginning to emerge, but it's all very basic stuff. But your car is connecting to a metropolitan network to negotiate as a crowd with all the other cars in the city. So that's okay. But some of these cars are going to be owned by crooks. Some of these cars might hijack your network connection and lead you astray and then steal your car or rob you or murder you. That doesn't sound very much like fun to me. So security has a location-based aspect to it as well. It's not as simple as just one of scale, millions, billions of devices. The whole notion of device registration, provisioning, failure, security. The farmer in his field, on his farm, agriculture is going to be transformed. So if you have, say, dairy cows for milk, they're all cows, they're all female animals, aren't they? But every now and then they have to be impregnated by the bull or the veterinarian, to reproduce and create more cows or beef. Now, interestingly, when a cow is ready to be served by the bull, it walks a bit funny. So there's an application where you embed a chip in the backside of the cow, and when the cow starts walking funny, you get on the phone to the vet. Daisy is ready now. And I can hear some people out there thinking, I can hear laughs now. Can you do the same with women? Someone's going to think of that. Some idiot is going to offer that as a solution to a problem I don't want to know about. But the farmer's going to sit in his Star Trek control center, and he's not going to visit the fields because it's all the sensors are out there. He knows when it rains, where the fertilizer is. He knows which plants are growing, which ones are not. He's got driverless tractors cultivating, planting, tilling, all the stuff that farmers do, and his cows are all chipped. So he knows where the cows are and when they're ready to be milked, to be inseminated. That's a different vision of architecture, agriculture, than I think most people have in their mind. What are we going to teach our kids about farms? I've just thought of that. What are you going to teach kids? It'll be a guy in the operations control center. There'll be no such thing as like the birds and the bees and the cows and the animals. It's going to change so many things, etc., etc. Okay? Am I boring you yet? Big data. I'm about halfway. Big data. Big data has been hype for the past 4, 5, 6 years as it's been around. I met a guy who was a big data guru, and he actually said, don't tell anybody, but most people's big data you can fit on a memory stick. It's all hype. But with the Internet of Things, that's when big data really does become big. In a medium-sized factory, it will collect a terabyte of data every day. 1,000 gigabytes of data every day. That's a 500 to 1,000 person factory. That's not huge. Because the machines are being delivered with all the sensors and instrumentation and all that stuff. It's all going to be captured. What anyone ever does with it, I don't know. But data is going to be just astonishingly large. 1,000 times bigger than we have today? I don't know. So we can't look at individual rows of data so much. We're going to have tools to analyze and visualize our data and give us statistics that we can see from pictures, not just flip through pages of data and see by eye. Those days are gone. We're going to have a whole range of tools to do visualizations we've never had before. The whole notion of personal and corporate privacy. I don't want to go there except to say, Big Brother will be watching you. That little buzz above your head might be a drone and it's got a camera focused on you. Who knows? I don't know. But not all systems will be huge, complex, whatever. A lot of them are going to be very simple applications, so fitness monitors, they're dead simple. They really are. They're very clever, but they're not complex. Okay? The stuff that I'm talking about hasn't arrived yet, but I bet IBM, Cisco, Microsoft, Oracle, they're working on this stuff right now. And they're going to buy these little maker companies that have interesting projects, interesting products. So we need to be thinking about the risks and how we tackle them now. We have an opportunity. So what's the test strategy? It's like, get out of testing, isn't it? Have you heard enough yet? We don't yet have tools that model the Internet of everything. I don't believe. There are tools which model things like air traffic control, but they cost millions. And air traffic control is dead simple compared with a smart city. We have the tools, but they are terribly expensive. They're expensive by 1 or 2 orders of magnitude. They're going to have to come down in price or be open sourced or given away, or I don't know, okay? Some of the tools we need do not exist, and no individual can knock one up in an afternoon in their bedroom. It's not going to be like that. We also have to think differently about how we test against requirements, let's say. If we have a city like Kuala Lumpur and 100,000 cars converging, doing all their stuff and then leaving or parking or whatever, crashing, who knows what, the simulation we have to run requires that we use real location data for the real streets. Otherwise, the test is meaningless. So we can't just generate a random set of locations for our cars and press the button. They have to be locations that are sensible. We can't have cars all in the same location. We can't have cars appearing on a one-way street the wrong way around. We can't have cars appearing in the middle of a theatre. It's got to be coherent data. Creating coherent data is one of the most expensive things we can do as testers. It's really hard work. Your test data is the most valuable asset you have, isn't it, for bigger systems? So we're going to have to look at pattern-based test design. So what's the requirement for my 10,000 car scenario? Oh, I've got to monitor every one of 10,000 cars that they all drive perfectly on the road. No, can't do that. We're going to run our simulation for an hour, and then we're going to say, okay, my magic tool that doesn't exist yet is going to tell me which cars crashed. They're exception. I should look at those. Which cars took longer to reach their destination than a threshold that I chose? Which cars failed to reach their destination? Which cars got there very, very quick? Something wrong there. How is that possible? Which cars disappeared from my network? There was 10,000 and now there's 9,000, whatever. Or we started with 10,000, now we've got 10,300. Where the hell do they come from? It's going to be things like that. So we're not going to monitor the performance of a single car. We're going to look at aggregate requirements. And that's going to be the only safe way we can do things, because it's just too complicated to do it any other way. So in order for this to work, we have to get our developers to understand right from day one that they have to build systems as testable systems, because that's the biggest problem. The problem isn't building these things, the problem is testing them. That's the problem. So what about environments? Get used to testing. Yeah, we've got cloud and all that kind of stuff, fantastic facilities nowadays, great. However, we are going to be doing a lot of testing in the field, and Barcelona, as an example, I know a little bit about it, I've set up what they call the Barcelona Urban Hub, which is basically a free-to-use, with their permission, environment for you to test your gadgets, in effect. And there are some criteria, some caveats to allow you to use these things. But it has to be of benefit to the community in the city, in effect. But watch out, most cities will have a live proving area, if you like. That seems to me an obvious thing to do. Tools are not going to make testing easy, they're going to make testing possible. For the systems at scale, we can't do this manually. The numbers are just sky high. There's no possibility of doing this. The problem we have is not test execution tools. We've got those. It's tests at scale. Who's going to create 10,000 coherent tests or 10 million coherent tests? We're going to have to use some techniques that we haven't yet invented to generate these coherent test cases, let's call them. It's possible. I've got ideas on that, and I think actually we can scale up some of the ideas that people have been using for many years, but it's a different discipline from creating tests one by one. It's a different discipline. That's the point. Analytics, John talked about the SMAC stuff this morning. Test analytics is an extension of analytics into our development processes. Most of the useful data that comes out of our development processes is test metrics. I've argued earlier that DevOps are things to watch out for that. I think that's the way it's going. And it's an interesting way to look at stuff, to regard your processes as things to be monitored, like things on the internet. I told you I was only halfway. Performance testing, the problem we've got at the moment, which protocols do we plump for? Well, all these companies are in competition. They're all promoting different standards, what they want to be a different standard. So it's a mess. It's great fun for consultants because there's so much stuff going wrong out there that we're going to have a field day, I guess. I wouldn't want it that way, but a lot of people are going to take advantage of that. Coherent data, big problem. I mentioned that before. You can't just create random tests. They have to be meaningful scenarios for this to work. So my argument is this, that in order for this to work, we have to change the way we think about testing. So again, without boring people too much, because some people have seen this twice now, is I want to suggest the way we think about testing is different. We have to, I argue that the way our brains work when we test, if we clear away all the crap that gets in our way of thinking clearly, of thinking properly, this statement in red is how it is. We explore sources of knowledge that might disagree, that are never complete, that are always fallible. We build models in order to understand the complexity, to simplify the problem, and with those models it informs our testing. We select tests on the basis of our models, of our understanding, not our guessing. Too many people guess at testing right now. So I've no time, I'm sure I'm overrunning, but there's a picture of a model that I presented to some people on Monday, about 25 of you. Got to mention lunchtime, I urge you to have a look at it, just to challenge the way you think about test. It might help. Manual versus automated, I think it's inevitable we'll have to use tools. Okay? I think I've made that point more than once. Should testers learn how to code? Well, I don't want to get into a bun fight about this, but I think yes. I think it could be a really fun thing, playing with Arduinos and Raspberry Pis and stuff like that. It's just fun. It's really good. It's good fun. But it gives you an insight as to how software works and how perhaps we can test things, because you have a deeper insight into the architecture and the structure of code within these complex systems. Some people are shifting left, moving testers into development. I think that's a positive thing. I think it's one step towards continuous delivery and DevOps, which might be the way we have to adopt to implement this Internet of Everything. So, okay, to close. I've kind of talked for too long, I think. The strategy for testing the Internet of Everything is the strategy for testing everything. I think we should take that kind of mission, if you like, and say, forget all the crap that's gone before, let's just start again a little bit. Let's think back to basics. How do we address the problem of testing untestable systems? And part of that has to be, we have to encourage our developers to take responsibility for testing earlier on. We have to ask them to take responsibility for making our systems testable. We have to have the hooks and connectivity in order to test things properly. My argument with the model is it might help thinking this area, and it's an attempt to try and trigger some new thinking and maybe some discussion too. So I hope you can take a look at it and maybe give me feedback. I'd be very appreciative. And with that, without depressing you any further, thank you very much. think I overran quite a bit there. Get off?
Thank you very much to
Thank you.
Paul, Gerard, that wonderful session.